Okay, so we're going to pull down here. We did these. We talked about an outlier, and we're going to start right here. So if you kindly open your book, we're going to finish this up today. There's really not a lot to me meeting and mode. You guys, you know you should have the books when you sit down. You turn to page 70.
Yo, it. It's for me. It's for me.
I'm gonna jump in. Jump locker. What page is for?
70. Okay, so we're going to kind of pull together what you did in your lab on Friday. And we're going to talk about what your outlier does. An outlier is a data entry that is separated from the basic part of your data, the bunch of your data. It kind of sits out there by itself. It sits outside of your data, called an outlier. Now, sometimes we find an outlier is actually a mistake. It shouldn't have happened. And we have to investigate that. Sometimes, yeah, an outlier is a valid time that this happens. For instance, I give a test, and pretty much everybody scores 60, 70, 80s. I get a 20 on the test. So that's a little bit alarming. So I investigated. Oh, okay, that student had been absent for 4 days, never got the notes, didn't work on the work that they missed. So I expect them to get lower. That is a valid outlier. If it happens that, that student is working, maybe not up to where they're supposed to be, maybe I need to worry about, is this student belonging in a college level class, or the student needs more help, or something like that. So when you have an outlier, you really need to investigate your outliers. They could be totally valid, in the case of my student who is working hard, or they could be invalid, like my student was not here for 4 days and took the test anyway. I wasn't paying attention, I gave him the test, and he hadn't been here for 4 days. So do I really want to count that 20 for him or for my class? No. I want to take that outlier out. For the other 20, that student's working hard, needs to work a little harder, but that is a valid entry. So outliers, you need to kind of know what's going on with your outliers. When you look again for your measure of central tendency, you want to make sure that it does represent the center of your data. So in example 6, we take a look at this data they want us to look at. They want us to find which one is going to be the best measure of central tendency. The mean, the median, the mode. Now, what's the first thing you notice when you look at this? The last one, the 65. It's called what? Outlier. It's away from my data. My data looks like 20, 21, 24, somewhere between 20 and 24, and then I have a 65. The middle is always going to be the middle, the physical middle of your data. No matter if I had, 64, 63 on my outside, it's still the middle of my data. That's not going to affect it. It's the middle number. But the mean is going to be affected in this. So how do I find, on your calculator, the mean, median, mode?
You have to go to stat.
Stat.
Edit.
Edit. Put the numbers in.
Again.
Then stat again.
Out.
Then count.
Arrow.
One pair stat.
One there.
And then put L1.
And you only need the L1, right? We have no frequency. Enter. And get your
Numbers.
information. Now, you're going to get your mean. Your mean is your S bar. Your median is when you scroll down. Your mean, by rule of thumb, is one more decimal place than your data. So if your mean has to come out with a decimal, go one decimal place. Your mode, you're going to have to eyeball this. Remember, you can sort ascending, so you can group them together. They are sorted in order. So you're just going to have to figure out which one has the most. So we got 6 20s,
Oh.
4, 4,
Mhm.
3, and 2. So what's your mode?
20.
20. Okay, and they calculated, both they school let them calculate the mean for us. 23.8 years. And your median is the guy in the middle. And the median's 21.5 years.
21.
Now, when you do this, and this falls in the middle of your data somewhere, right here, right there, your 21, 25, that's the middle. Your 23, look where your 23 is falling. Closer to over here. 23 point, I guess I have the same color. 23.8, your median is the exact center, but your mean is pulled off to the right. That's the effect of this outlier. It's pulling the mean to the right a bit. Now, we're gonna go through a couple of rules here and see what happens in this when we take a look at these, where your outliers lie. Normally what happens is this. Your mean, median, and mode sit together. If you have an outlier to the right, it pulls the mean away. If you have an outlier to the left, it pulls the mean that way, towards the outlier. Makes sense, right? Because you're adding in that number. So it's either going to drag your mean to follow the left where the outlier is, or drag your mean to follow the right. So in this case, we want to use the median as our center of our data. Now, if we remove the 65 from this data set, let's take this out. We have no more outlier. Those numbers are really, really close. Your mean and your median will be the middle of your data. You'll be able to use either one because your numbers are close together. They have a relationship. So did anybody put this in your calc? Everybody put it in? Put it in without the 65 and let's see what your mean is. Did your median change? Your median might change because we removed a number. It'll be 21. Your mode, did your mode change?
No.
Nope. We still have all those 20s. And your mean's going to change. So if you kindly calculate that, down to 65.
Here.
It's actually 410. What's 410 divided by 19? What's 410 divided by 19? Huh?
Just put 410
410 divided by 19.
Wait.
Four.
I can't hear. I can't hear.
21.
Oh, 10 divided by 19.
7, so 21.6.
21.
Guys, I need it quiet.
21.3.
21.6?
Yes.
Thank you. So, you see how close these are now?
Yeah.
You can use either one. Would we want to use the mode? No, the mode's not close to them. And very, very rarely do you use the mode. Unless something's uniform, then you'll use your mode. But so your mean now is back to being the middle. Whenever possible, use your mean. That's what people understand most, the average. They use the word average when you're looking at these things. Okay. Oh, well, that's all right. Now, the next thing we're going to look at is a weighted mean. A weighted mean. Some of your teachers do your scores with a weighted mean. I used to do it this way. Now I'm back to a point system. But some teachers will do quizzes are worth, and I used to do mine, 30%. Tests are worth 40%. And homeworks, classworks are worth 30%. Together, guys, they have to add up to 100%. But they're weighted because tests should have the most weight in your grade. So what you do in a weighted mean is instead of adding up all the things and dividing by how many you had, You figure out your average for your quizzes. So say you averaged an 80 on your quizzes. On your test, you didn't do that great. You averaged a 70. On your homeworks, you did all your homeworks and your labs, and you got 100. Now, normally we would take all these, add them together, and divide by 3. But the weighting system says you're putting more weight right here on that grade of your test. So how you work a weighted mean is you multiply it by that percentage, 0.4, and you get 28. You multiply this guy by 0.3, your percentage, you get 24. You multiply this guy by 0.3, and you get 30. And then you add this all up. And your grade would be an 82. Versus taking 250 divided by 3, which is probably close enough. Might even be the same. But your weighted score says take into account that these are weighted differently. And a lot of teachers base their scores on weights. Your assessments should be higher. My homeworks have always been high. Some teachers count their homeworks like 10%. I always felt homeworks is important for you. So if it's 10% of your grade, and you could start out with a 90, like why bother doing your homework? That's what I would get from somebody. Why bother doing it? It's 10% of my grade. Because it's a weighted grade. But your homeworks in my class are always 30% because my theory is your homework is how you learn. So I'm willing to give you a higher mark because I need to see you learn better and learn more. So I weight my homeworks a little higher. So your weights have varying ways to do this. That's all a weighted mean is. So here's another example. Here's another example. All your weights have to add up to 100%. They always have to add up to 100. Now, here's a series of things. Your test scores averaged 86. Your midterm was a 96. Your final was an 82. Your labs a 98, and your homeworks added up to 100. So the weighting system was 50% for tests. Midterm, 15%. Final exam, 20%. Computer labs, 10%. Homeworks, 5%. Altogether, they have to add up to 100%. So you multiply it by its decimal. These are all multiplied across. And then you add them up. You take the total. And that's how you calculate your final grade. Okay. Your final grade is calculated that way. Some of your courses for the year, your finals will be worth like 10% or 20%. If it's worth 20%, and they take all 4 quarters in your final, add them up, divided by 5. If it's worth 10%, then they only multiply that column by 10, and they count the other ones by whatever that average comes out to be at 90%. So sometimes your finals have a stronger pull if they weight it with more. I weight mine 20% because I think it's a strong representation of your grade. Sometimes regions aren't calculated in your grades at all. So your 4 quarters are each 25%, and your region's grade is not figured into your overall average. Did you guys know that? Your regions are usually standalone grades, which I disagree with because they didn't used to be. They used to be calculated in your average. But sometimes they're standalone grades. Now, if you replace your final exam, this 80 with a 98, which category is going to change? Just the final exam. We're going to multiply this guy by 2. So if I multiply this by 2, I get
19.6. 19.6.
19.6?
Yes.
Right, 19.6. Now, that increased your average by 3.2 points. So we would just add your 3.2 in here. And that made a big difference. because that is 20%. That is 20% pull in here. As does your test grade, your final scores, your finals. Let me just say a little something. Okay, so just so that you know, don't blow those off. That can make a big difference in this. Okay, the last thing we want to look at is a frequency one. What happens in a frequency is you have a table like this. Oh no, you don't have a table like this. Okay. Take a look in your table. On page 72. Okay, this is the same table. Okay. You have an X value, you have a frequency. Now, you guys aren't going to have a problem because most of the time you put this in your L1, you put this in your L2. Now, here's the difference in your calculator. You have to say stat, calc, L1, one year stat, comma, L2. If you use the yellow one, L1 is here, frequency has to be in L2. So this is what your calculator is telling you to do. Multiply this times this. Get this. This times this. This times this. All the way down, this multiplies with the frequency. Then it adds up this frequency. It adds up this column. It adds up this column. Then it divides this. And that's where your grade comes from, your final answer comes from. But your calculator does it for you with an L1, L2. But it's really, really important not to forget your frequency. Because if you forget your frequency, it just takes your X values and finds the mean of that. And you can see where, like, these guys have a stronger pull than these. So it's not taking this evenly. You can't take the average of this piece. And your calculators do this for you, which is a nice little trick to do. And you remember this from Algebra 2? Pretty much when we did these in Algebra 2. We do mean, medians, and modes pretty much every year. We do in geometry. This Algebra 1. Okay. And the last piece is when you have a class. Now, when you have a class and you're going to put this in your calculator, you go to say L1, L2, you have a little problem. You can't put 26-34. So what we do is we approximate this. We can only approximate the mean. We use the midpoint of this class. This is now our L1. This is our L2. We use the midpoint because you can't put this in your L1. You can't do this either. There's nothing to multiply here. So instead, we use the midpoint and we multiply with the midpoint. Then it does the same thing. It adds them all up. It divides by the frequency, total frequency. So you're going to use a midpoint. And by doing this, we can approximate your mean. We can find your mode. We can find your class with the highest mode. And we can even say the midpoint. When you make your frequency histogram, don't you use the midpoint sometimes? Or the upper class boundary? Most of the time you probably use the midpoint. This is where you see your midpoint used again. And the median also. How would you find the median for this? Well, without your calculator. How would you find the median? We can find the mode. We can say the class 53 to 61 has the highest mode, has the highest frequency.
Find the median in the class.
Nope, find me the median, the class median. No, the median, which class represents the exact middle of your data?
Did they put it in order?
It is. It is in order.
It's the one that
Hmm?
the 53 to 69 change.
51 to 60. How did you know that was the middle?
What's it say?
Well, it's the middle of your table physically,
Yeah.
but your middle of your data is sitting right here. So to find your middle, isn't it the exact middle of all your numbers? So you add all these numbers up. You're going to add these numbers up. So this is going to give us 37, 48, 49, 50. Okay, now watch. 50 divided by 2 is 25.
Sure.
Do your cumulative frequency. So start at 2. Add 5. Add 12. Add 18. It's wherever this number falls. Wherever this number falls is the class. God bless you.
Unless,
That contains the median. Now, up to this point, you did 19. From here to here, you got to 37. That's where your 25th entry fell. Just so happens it sits in the middle of your table, but it's just because of the way the range of your numbers are. This is the middle, and these kind of balanced out. But you find the exact middle of your data, what number entry that should be, and do your cumulative frequency and count down. Granted, when you do your L1, your L2, it gives you your median based on your midpoint. Because you're going to do a midpoint, and it'll give you the median with that midpoint. The mode we find with the highest frequency, the mean, we multiply using your midpoint. Okay. And the last part of this is your shapes. These are your shapes. A uniform and a skewed. And your normal curve. This guy, we say this is symmetric. We also say we're going to be calling this a normal curve. Many of the times you're going to see in your book, it's going to say approximates a normal curve, approximates a symmetric curve. A lot of these things you can't do unless we have a symmetric curve. So this is the one we're going to work with the most in this course. Your mean, your median, and your mode fall in the M's, the middle. Mean, median, and mode fall in the middle. But look, there's your highest bar. That occurs the most. That's the middle of your data. And it's got to be the mean because everything is symmetric on both sides. So your normal curve, that's the most symmetric, has the mean, median, and mode in the middle. Now, this guy, this is called a uniform distribution. And it's fairly uniform. Sometimes it doesn't come out that perfect. You'll see one bar a little higher, one bar a little lower in here, one bar a little higher. It'll say approximately uniform. Your mean and your median sit in the exact middle of your data. Your mode is whatever the mode happens to be. They're all the same mode here. So if this is the frequency of 20, everybody has a 20. Every class has a 20. So there's technically no mode to this because everybody has the same number. Skewing, when you skew, and this is what I was hoping that you would find when you did this. It follows the tail. And you have to know this. As your tail comes down here, it drags your mean towards the tail. Question, Rachel? Your median and your mode mostly are together here, a little bit apart because depending on what your mode turns out to be. But your median is always in the middle. The mean goes towards the tail. This guy, do you see this guy over here? That's where the tail is. So the mean is to the right of the median. That's how you can tell the skewness. So we call this the skewness. This is the skewness of this.
So the tail's the other way than you.
The tail's going to follow your, the mean is going to drag towards the tail. That's what I kind of wanted you to see when you did this. It's kind of like pulling towards your outlier. It's pulling towards your tail. Questions? No? All right, I'm gonna give you a little homework assignment. You're gonna have to take this home. You do. Very good. Okay, write these down. Some of them are just matching. I don't think it's going to take you a really long time.
Whoa. Ooh.
If I finish them, I'll get big.
You can bring it back. I'm here in period, the beginning of period 9. I asked for the lunch for you today. You can bring it back. You have time during your day?
Yeah, I have 3, 6, 7.
Okay.
That's what I'm saying. I'm gonna have 6 and 7 degrees the day class is. They're trying to get me. They didn't do it last year. Bro, they're trying to get me 6, 7, 8, 3. So 9, 3, 30 something. Second half of the year, I get out after.
Okay.
Good period.
I'm figuring out a test for 2.2 and 2.3 by Friday. So this ends 2.3, so we'll go over it tomorrow, do a little review tomorrow and Thursday.
Oh, you said a test on Friday?
Yeah,
Oh, man.
test on Friday, 2.2 and 2.3. They're easy. No, we'll have 22.4 and 2.5. We'll show you.
Like a one
Hold
little
up.
thing.
Yeah.